Well, hello there and welcome back to another video. In this video I will share with you how Clean Ovac works, how I made my decisions for him, and how you can build him yourself, or at least how I did it, the most things. And since he made it through a whole day at the convention, he's now ready to go. So let's just hop right into Fusion. So here we are into Fusion 360. This is his full completed model of Clean Ovac. And so I would say this time, since from Mr. Helpful we started from top and go from the bottom, we start from the bottom and go to the top, because like he is a bit different. So let's just start with that. So, and here we are at the bottom. This is his drive base, what I call at least, because this thing allows us basically to, let's say, because we have, let's say I am working or currently like in process of making other animatronics. This allows us to use his main thing, also the drive base, which has the most important things on it. So to drive the animatronic first around, second to have the Arduino that controls everything, third and also like the step up or step down converters and so stuff like for the batteries. And so let's just start with that. So this is his drive base, this is the front and this is the back. And so in game basically he moves you can say kind of omnidirectional, because in game he turns on spot but also makes smooth turns. So he basically sometimes drives like a normal car. So basically if he drives and makes a turn, then he makes a smooth turn instead of like stopping and making like a direct on-spot turn. But also sometimes he turns on spot. Anyways, this allows us to do that. And in theory, it allows us also to make other omnidirectional movements, like going sideways or so stuff. And so basically this allows us to do that. And let's just jump right into it. So we use 4 motors in total, 4 DC motors. These motors are Pololu 19:1 gear ratio metal gear motors, which are the 37D X52L. These are 12 volt motors, and they work great for it, because like they give enough torque due to the gear ratio. And so he can easily drive up, let's say, inclines a bit or so stuff. And they give enough power, and they're fast enough, definitely fast enough. I even kept him so he can maximum drive the motors up to 60% instead of 100%, since he's just way too fast. And and these wheels I use are Mechanum wheels from Go Builder. These wheels are 104 millimeters in diameter, and these are from their Grip Force series. So they give us a lot more grip on the ground, and so he can easily drive. And so the drive base has also like here this top plate, which attaches via 2 or 4 screws in total to the main drive base. This plate holds basically the Arduino, like I said before, and like the other stuff. So the step down converters, the motor drivers, and so stuff. So just the main things. And so basically here on the, or basically not this one, it's the other way around. Here, this one is for the Arduino. These holes, these are a bit up. And then here on the middle, there are these 4 holes, 1, 2, 3, and 4 for the motor drivers. And then we have in total of these 4 for the instead, like he has these 4 not holes but like pillars that stand up. These are for the step down converter, for the big step down converter. This can in theory, just in theory, if like the motors would block and he would drive the motors up to 100%, then he could max them out. So in their ampere rating. So this a big step down converter can easily make this whole drive base work. And then here are also other two pillars for another smaller step down converter. This is for the servos and so stuff. Yeah, just that the original voltage that comes from the batteries, from the two batteries, will convert to a lower voltage with an higher amp count. So anyways, so if we remove that, here we have the drive base itself, or basically we have also like the two side panels that we can attach, and yeah, basically. Now then, here is the drive base, how I attached it, because like you can see here's not really, this is one piece to print. In theory you can also split it up like I did, is if you want to make it like I did, because like I didn't make here in Fusion direct attachment holes or something, I attached it permanently together. So what I did is in the slicer to say, okay, I have this drive base, I cut it right here in the middle. After that, I printed it out in a relative high, let's say, in a high infill count. And yeah, after that, I put the motors inside. These are press fitted, by the way, so you would have to apply quite a bit of force to get them in there, or really just maybe, it really depends like in which layer height you print it and whatever. But basically these ones press fit inside there, so they are really tight in there and they should not be moving anywhere. So yeah, what I did is basically put them inside in each side. So we then, after it is split it in the middle, the model, we have the right and the left side, and then we can say, okay, I just said we just put them inside, then wire the two wires up, and then after that we basically attach these two sides permanently together. After I tested, of course, also the motors, because not that something doesn't work with a power supply. I tested each motor again if they really work. After that, I attached these two sides permanently together by using different techniques, like first up, due to the high infill count of this print of the drive base, I just first up used a soldering iron, a cheap one, just got basically almost everywhere where it splits in there, really deep in there, and just melted together. So this is a permanent bond. After that, I also, since the most like these bonds, you can of course fill them in with, like, let's say more filament, spare filament or so, but what I did is also to say, okay, instead of filling it in with like the little bumps and so on of the holes what we made due to the soldering iron, of course I filled it first in with the rest ASA filament. I later on said, okay, let's permanently even attach it even stronger together by using resin, UV resin, and also on some parts I even applied not UV resin but some a 2-component glue, or not glue, resin basically, which is attached with a bit of carbon fiber. So this is a really strong bond, this drive base, and this should not break. I even tested it with a dummy drive base without the motors, and this right here is really strong. And also, before I even did that, I also used a plastic welder, so with these little metal wires that burn into this print, and this is really basically permanent, this drive base. After that, I assembled the whole drive base with also like the Mechanism wheels, which have also from Go Builder this little hub which can attach directly on the motor and then also to the little wheels. Now then, after that, if we, let's say, attach, where is this has also like this covers for inside then of Clean Ovac if you want to use it in theory for dirt and so on, just that it doesn't get inside really. We have these covers which attach on it, and then also let's say we attach this one, and where is it? We get to the housing. This is the next part, the big part, because the housing consists of 3 parts in total. First up, the main housing. This is this big thing. This thing right here took me a way too long time to sand. This really is just insane. This is one part. This I split it up basically in the slicer. You can see it also like later in the file. I split it up in multiple parts. If you need to, you can also resplice it, since my printer is a bit bigger, but you can reslice it or splice it the parts to make it even smaller and fit on your printer. Really depends. But yeah, like print this in a low infill and just maybe a bit more wall thickness, just that you can also again from the inside only glue or basically melt these parts all together. Then after that, so also what I forgot to tell you, this whole housing thing attaches to the drive base. So the drive base has here 4 holes, so 2 on the back and 2 on the front, and basically these holes allows us to say in the housing what we can we see that? Yes, we can see it a bit. Like right here, we can see this housing has basically here a connector where there are in total 4 M10 screws or bolts in there. So this thing will not move and is permanently attached on that. So yeah, anyways, so this is the main part of the housing. Here are also 4 holes or 8 holes in total for basically the battery mounting. So since we use tool batteries, there are multiple tool battery dischargers, or basically how can I say that, basically attachments which you can use. I used ones from Go Builder again, since they have a bit of protection systems that if let's say something short circuits or something happens, the batteries won't be damaged. First up, this shuts down. This is important. But yeah, anyways, these attach on there if the batteries are too big, because this is what I also found out. It really depends also on the size of the battery, since we have this housing. It consists of 3 parts in total. So the main housing, then the housing back part. This is like the back attachment. This attaches also right here via 2 M10 bolts, and then here are basically the battery modules. And if it really depends, on the batteries which you use, which tool batteries, because some tool batteries may be bigger, but they give you a bit longer run time. In total, since at least in my build, since I kept him at 60% of the motor power and all other stuff doesn't draw too much power, in total he would run around like from 8 hours upwards to 16 hours. Really depends how much you do with him. But yeah, anyways, so it really depends here of the battery size. In total I have 2 8 amp hours batteries, so in total I have 16 amp hours. So yeah, and these are a bit bigger, so I needed to basically say, instead of using 4 holes of them, I just use 2. I use 2 holes, and these holes are a diameter from of basically here 4 millimeters. So you use M4 screws for that, and yeah, anyways, so and then also the housing has, or it consists in total of 4 parts, what I just saw. But anyways, then there are also 2 other parts, like the battery hatch. this is basically here the attachment for the batteries, so you cannot see inside directly. Here's a little handle to open it and close it. From the inside I just glued a little thing on there, and yeah, anyways, so then we have right here, this thing is allows us basically to say, okay, here we have 1 or 2 neodymium magnets, which we will also see later for the tube. And then we have also, where is it? Here's the tube, and here. Then we have another attachment of this. And basically what I did is either you could say you print this tube right here out, and you this is included into the files. Either you print it out, you paint it, and so on. Or what you could also do is what I did. There's another tube. Basically, this is quite a bit smaller, since old vacuums, or maybe you can find it online or so, or used a tube from a really old vacuum, and then just cut it apart at the right size, get it over the other tube, and then basically you just attach it on the just the magnets on there. So yeah, and basically this detaches, this tube detaches and attaches via these magnets. So this is really on there. And then here on the back is the rest. So the last hatch, this hatch is basically just to say, okay, where is it? Here. This hatch is just for the electronics, if you have to reflash them, so the Arduino Mega and so on. But yeah, just to open them and just to, let's say, yeah, wire them up and so stuff. Yeah, makes it a bit easier, or yeah. Anyways, so after that, so this is the housing. We'll have to remove it again, since we want to see inside, of course. And yeah. So next up, then after that we go basically to the front of him. So we have right here in total of 5 connectors in total. These holes or connectors allows us to say, okay, we have, where is it, right here, the vacuum pot upper part and lower part. These are also like from the ground up splitted, and you just have to, and then later on basically attach these two together. And yeah, and so what this allows us to do is basically to say, okay, on the other side, so on the side from this vacuum attachment, there is also holes, and this allows us to say we have right here basically where is it, wait, this one here, this was around 10 millimeters so in diameter, so you just use a 10 millimeter let's say aluminium rod, or a carbon fiber rod would also work, and just attach it on the side from this vacuum attachment, and then just slide it in. But on the other side, if you have it in with these 3 right here on the front, then you go inside, and then it's a bit trickier, since you just have to, since this can like rotate up and forward, up and lower, downwards, you just have to look that you align this with this hole. So the other hole on this side, you align it with this hole, and then go inside and attach right here. You go here and just say, where is it again? Yeah, you just go inside here and just attach it via here inside. So you just put from here inside the carbon fiber or aluminum or steel rods inside, and just attach it via that. And yeah, then it's on there. After that, basically this is his vacuum attachment, and he is pretty low on the ground, so you will have to always look for that, since he's pretty, let's say, prone to get stuck somewhere, since this is not much space between the wheels, and the vacuum attachment. This can sometimes rub on the ground, really depends like how the ground is and so stuff, but on flat surfaces this will work perfectly, so he will drive perfectly. But this is Clean Ovac, so if we would like say it, we will put this a bit more up, this looks not anymore like Clean Ovac. So yeah, anyways, on the other hand, let's just go ahead and get to the main stuff. So first up, the arms. The arms attach via these connectors right here. If we see it, let's just get it away again. We have here basically so like sliding mechanisms. So after you printed this whole housing, just note that these ones, at least like how you splice it, or if you splice it again, these ones have to always be 100% in infill or so, and really smooth from the ground up. You can always smooth it in the afterwards, but yeah, these have to be smooth, because after that, these arms, so because we saw it also in the trailer and so on, and in-game sometimes, that he swipes up the ground. To do that, if we remove this one, the housing again, we can see these tubes basically rotate outwards. And what I did is basically say, okay, you can attach these things if you because these consist of these two parts. This is just a temporary attachment from before, but in reality these are not here, because I just saw a few problems afterwards and decided to make it a bit different. Anyways, so basically here's the servo. So we use again the 20 kilogram servos. These are pretty strong and have enough force to drive them. Basically we also grease these little things here, just that it slides more easily and more out and inwards the arms, so the servo can easily drive it. And yeah, so basically how this works, basically this servo is perfectly centered in the middle. In the housing itself, if we look at it, now we have to look at the other side. You can see right here, these ones have here two attachments. You just have to look that it is on center, or basically on it's really horizontal. After that, it's perfectly in the middle. On the other side, this is the same thing. And yeah, so basically after that, so if you attach these servos can make the arms go out and inwards. But if we think like this, the arms have to first up go outwards. So for that we use linear actuators. These arms basically, if we say we open the arms, so these arms consist of multiple segments. So basically this is just a sleeve. This prints in one piece that can go over this linear actuators. Basically this one attaches on that, and just via 4 magnets. So first up, if you print this arm piece right here out, you will have to attach it first. So the linear actuator, because it's a bit tricky to get inside, really depends like how you do the cable management. I made it with little XT30 connectors, just that it is really on there and doesn't detach from itself, and so on. And yeah, so basically what I did is say, okay, we have here 4 magnets. So again, neodymium magnets, just that this sleeve fits over the original linear actuator, and yeah, this covers it a bit up. And yeah, so then right here, after the linear actuator is inside, you have right here a little hole to go to put the cables through, and then you basically slide these pieces in. After that, you have basically to say, let's attach these ones, but we'll get to it. Then later on, if we detach that again, we can see right here the hand exists of 2 parts also. Like first up, this ball piece. this ball, if we remove the linear actuator, this is perfectly fitted inside there, so you will just have to glue it inside there, and then it's on there, this ball piece. Because this ball piece allows us to say we attach it right here, is a attachment for a really tiny ball bearing. You just press fit it inside of here. This right here is a total diameter of 15 millimeters. And yeah, after that, basically you just press it in, and like that it attaches the arm. And yeah, then for his broom and his little shovel, I made it manually. So afterwards, what I did is basically say, okay, let's align it. So I will look at the front, see that because these are not at the same height normally, or at least they have not the exact same length. Like that, I have to paint it a bit different and so on. So what I did is just manually say afterwards, okay, after painting, let's just put these somewhat exactly in this position what I want, and then attach it right here via a little tape, and then like drill through that from the back. After that, you just have to basically drill through that arm piece or hand piece right here, and through the broom or shovel on each side, but not fully through. So just that you don't get through the whole thing, but just you really have to be careful just to say, okay, let's just drill through that and through the broom or arm piece, just that it is attached on there. And yeah, on the other hand, after that is done, yeah, this is basically the arm piece or the arm pieces. So yeah, basically after that, there's also yeah, and also one other thing. The attachment of this, how he drives it, also like we can right here see this one, this little piece that attaches right here. I removed that in total because this is a bit actually was a bit of a stupid idea. If you think like it, we would have to make it again convention ready. So let's say since his arms are a bit, let's say, brittle, so they can easily get damaged and so stuff. At least not the linear actuators, since they are out of metal and so stuff. But like this, he could easily is prone to movements, like quick movements, at least from the servo. So what I did, basically, if let's say we bump into something or someone bumps into him in his little arms again, then we can easily attach it again. What I did is basically say, okay, right here, this is removed, and so like that, and this so the 20 kilogram servo has here, of course, like these holes, and I attach like a really long screw through that, and then basically attach this screw with multiple nuts right here that is permanently on this piece. And then afterwards I also just made it like that I used a really super strong tape, basically, you can say, to say, okay, attach it right here on the piece right here and on the outer screw, just that if, let's say, we bump into someone also, the first thing that will break maximum will be the tape. Because if it would be stronger, or let's say let's say if it's stronger, it could lead to either the print fail, so this arm piece right here, or the servo something fails. So since this right here is also out of plastic, so the gear right here is also really prone to, let's say, quick movements or so. And like that, I just said, okay, let's attach it like that. So the first thing that will break is maximum the tape, so we can easily reach from the back inside and just attach it back on there. But yeah, anyways, so these are his little arms, and if we look at the housing again here, then we have just one thing remaining, and that is his head. In total, his head is right here attached via this platform. So we have one right here. There, here we have it. So basically how this whole thing works, of course his head is quite a bit wobbly. This really depends on what servo you use. You cannot use, of course, any servo in theory. You just have to adapt this a bit back and forwards, like really depends. But these are what I use, have quite a bit of backlash, so his head is a bit wobbly, let's say that, but on the other hand it works. So here is a 20 kilogram servo which drives his head left and right, and then like with his little attachment, I made a little adapter that attaches on that, and then I adapt it to the 25 kilogram servo, which is the up and down movement of his head. Where is it again? So head, yeah, right here. And this part attaches then later on via screws. If we go put them from here inside on his head, it attaches the head. And yeah, so basically then afterwards, if we look now at the head, his head consists in total of 2 parts. So first, or more parts, but in total the 2 big parts. So first up, the front and the back. The front consists also of 3 parts or 4 parts in total. Just the front, which is attached via many neodymium magnets. Of course, you do not have to attach every one of them. It in theory it holds also with like these big 3 and also a few of them upwards, and just 1, 2 on the side, but I attached all of them just to be sure, and this really supports the whole head. So whatever I do with him, so let's say he makes really quick movements with his head or so, or wobbles quite a bit, then it won't fall off. So yeah, then basically this mesh, so the head front grill part, this is also printed with the printer. This is really, you have to really be careful on that, since this is quite small, and yeah. And yeah, and of course his eyes. The eyes slide in from the front of his head, and yeah. Anyways, so, and then of course he has, and also that, where is it? I need that one, exactly. Then he has here 2 attachments for the little speakers, just that he can make his cute noises. And this is all one part. And on the other hand, here is just one other part. So if we remove, where is it? This one. Here we have his plate, which will glue on his head. What this allows us to do, or what allowed me to do, is basically to say, between these 2 plates right here, these are 2 plates, we have basically a little compartment, a really little small compartment, where we can put an FSR sensor, a force sensitive resistor. Which this does is basically say, okay, we attach it to a 5-volt pin on the Arduino. We put 1 pin of it on a analog input, and then 1 on the ground. What this allows us to do, read basically with also a little, so we attach this SFR with a static resistor, a 10 kilo ohm resistor normally, and you can of course make it more sensitive to like the thing. But anyways, what allows us this to do, if we put it here inside and just attach these 2 plates, so basically these are also then later on permanently attached after this has been tested. Also, what I did also is basically, like, say afterwards, if we just use the top plate, to say, okay, we put right here a little tape also to make it a bit more sensitive, at least not a normal tape, a little electrical tape, and basically this gives us a bit more of sensitivity. Anyways, so this, if we attach it to the head and to the Arduino inside, basically allows us to measure if someone touches him on the head, since he is able to sense that due to the SFR sensor. Basically due to the pressure, he spikes in the voltage, and due to that we can read it out and say, okay, if the value is over that, then make the sound or something. So basically he can react on his own. It really depends how sensitive it is. It is really a bit of a thing because you really have to look at this. But yeah, it works. So you can pet him, and then in my case I made him so that he plays cute noises and random noises. So really each time you pet him basically, and then he basically makes a noise, a cute noise. Anyways, so yeah, this is basically it. This is Clean Ovac. And one other thing, what I just forgot to mention, is also with this whole thing, with Clean Ovac in the model files, you will get also patterns. So basically you, if I find it again, where is it? Here, patterns or masking helpers or detail masking helpers. These are directly fitted on that, so you can easily, let's say, just print these out, put it on the print, and just paint over it. These help with, like, basically these are replacing traditional masking. Just do it, just print it, and then you have the perfect shape. Of course you have to mask around that, but yeah. So not only for that, but also for the bow tie, like right here on the top, like if we see here, yeah, for the bow tie, or also like for the main body, if I find it again. So basically this attaches on the side, and this gives you a perfect shape, and then you just have to mask on the other sides around it. And also, like, of course, for his main body, for the housing. But this is quite a bit, and there you have to really be careful, since this is really thin in the print. And if this, what happened also to me, if it unfortunately breaks the masking helper of this housing thing, then you just have to carefully attach it via super glue, and then just let it cure, since this is really thin. Just to, let's say, okay, because like he has multiple colors, but these have no really, let's say, between them there is no space. So I made one masking helper where you can make multiple colors in once. So with one spray attempt, so you just say, okay, let's put this on, and then just spray first the orange color and then like the blue color. So afterwards you sprayed so after you sprayed the main housing, you attach the masking helper, and then basically you just say, okay, let's put first the orange color, so the top color on there, and then you mask that. So you mask the masking helper, basically just the orange part, and then you can make directly also the blue part, and then after that you can like put it up, and really depends, if you're careful enough you can get a perfect result like I did. But yeah, so this is it for Clean Ovac, and